We did adding last day, so guess what? It's subtracting today with rational numbers. So our learning outcome is I want you to be able to subtract rational numbers. Well, subtracting is really similar to how you go about finding adding. Remember, when you add, the denominators of fractions must be the same, so it's the same thing here. There's a mistake here. This shouldn't say add. There should be subtract, so please change that in your notes. The denominators of fractions must be the same before you subtract the fractions. Actually, not the fractions, but the numerators. And subtracting a negative is the same thing as adding the opposite. So knowing these two things, we should be able to get through this lesson much quicker than last day. So let's try some examples right now. Number 1, 2/3 minus 5/6. Once again, are the denominators the same? And they are not. Let's make them the same. Multiples of 3, multiples of 6. Yeah, let's find the lowest one, which is just 6. 3 times 2 gives you 6, so 2 times 2 gives you 4. So this is 4, 6. 5 doesn't have to make a change because it's already a denominator of 6. So 4 minus 5 all over the same denominator of 6. That's just negative 1 over 6. Done. Please do the next one yourself. 8 and 5, they are different. So let's find the common denominator. Yep, if you said 40, I like it too. 8 times 5 gives you 40, so negative 3 times 5 is negative 15. 5 times 8 gives you 40, so negative 1 times 8. Oh, sorry, just 1 times 8 is 8. So here, notice we are taking now negative 15 and subtracting 8. You can think of that as adding the opposite if you want, adding negative 8, but negative 15 plus negative 8, well, that's just negative 23 out of 40. Once again, this is a nice fraction. The numerator is not larger than the denominator. We can just leave it as is. Okay. Part C, 10 and 6. Once again, different. So let's find the common denominator. 60 seems good, but if you can find me a smaller one, I'd be better or more pleased. Oh yeah, 30 right there, right? So change everything to a denominator of 30. Same process, 10 times 3 gives you 30, so negative 7 times 3 is negative 21. 6 times 5 gives you 30, so negative 5 times 5 is negative 25. Notice in this example now, I'm taking negative 21, subtracting negative 25, and once again under the same denominator of 30. Subtracting a negative is the same thing as adding the opposite, so add the opposite of negative 25, that's just positive 25. Negative 21 plus 25, that I believe is just 4, so 4 over 30, that's awesome, but I want answers in simplest forms. What do we need to do next? I'll ask you to divide both of these numbers by 2. And you'll get the answer of 2/15. So always try to reduce them to lowest terms. Okay. Ho ho ho, those were the easy ones. Now what about the mixed numbers? Well, once again, like adding fractions, we can actually do it 2 ways. So I'll show you the 2 ways once again, and you can decide which one you like. Improper fractions is the first one today. So, once again, can you change them to improper fractions? Don't worry about the negative, just take the number, right? The whole number, 3 times 5, that's 15, plus 2, that's negative 17 over 5. And then, don't worry about the negative, 2 times 4 is 8, plus 1 is 9. So here are your improper fractions. Now we can just follow the same steps as before. What's the common denominator? 20. Let's change them all into the denominator. 5 times 4, so negative 17 times 4 is 68. 4 times 5 is 20. 9 times 5 is 45. And now we're just subtracting. So negative 68, take away 45. That's the same thing as adding the opposite, so negative 68 adding negative 45. If you add them together, you get negative 113, I believe. You can use your calculator to check. Negative 68 minus 45. It'd be nice if I turned it on. Yep. Don't leave your answer like this once again, because I'd like you to rewrite this as a mixed fraction. 20 goes into 113, I think, 5 times. So 5 times 20 is 100. And you get the remainder of 13. So this becomes 5 and 13 twentieths. But don't forget there's a negative in front, so put that there too. That's it. Okay. Alright, let's try the second method where you're going to split up the integer with the fractions. So in this particular example, then I'll go and take negative 3 and also negative 2. Let's keep them separate. Once again, remind yourself that the negative applies to both the fraction and the whole number. So this actually becomes negative 2/5, and this is negative 1/4. We'll now try to combine. So we'll combine the integers. Negative 3 minus 2 is negative 5. We'll combine the fractions. In this case, the common denominator is 20 once again. 5 times 4, so that's negative 8. 4 times 5, that's negative, or just 5. And so now if we were to combine this together, negative 8 minus 5, that's just negative 13 twentieths. We still have the negative 5 in front, which is great because now both of these are negative. Like before in the adding question, we just factor it out, and we now get our answer, negative 5 and 13 twentieths. Didn't have to do that weird breaking up stuff as we did in our example in the last video, because notice both of these were already negative, so they had the same sign. We just had to take it out. Much simpler. Okay. That's fractions, and what's next? Yeah, don't forget rational numbers can also be decimals. So rational numbers are not just written as fractions, but as decimals that can terminate or repeat. Where have we seen this before? Yeah, the previous video. So I'd like you to do the same thing now this time. Use integers to estimate each, oops, this should not say sum. This should say each difference. And then find the actual difference. Can you see I did a copy and paste job from the previous lesson? So, same idea. I'd like you to estimate first because I think that's important, and then we'll do the actual. How about negative 1.9 being negative 2? Right, that's pretty close as an integer. Negative 14.2 is just negative 14. Negative 2 minus 14, that's negative 16. Okay. Negative 0.913, I think that's just like negative 1. We're subtracting here, and this I'd say is close to negative 3. So negative 1 minus negative 3, that's the same thing as adding 3, adding the opposite, so that's 2. And this last one here, 4.26, I think that's 4. That's probably negative 14. And that's the same thing as adding once again, so 18 is my estimate. Alright, go ahead and use your calculator, and let's see if you can find the actual answers. And let's hope that they are very close to our estimate. First one looks good. Second one looks good. What am I doing? 4.26 minus negative 14.2. That looks good too. All right. Okay. Oh, look at this. Subtract the fractions by converting both fractions to decimals. Okay. 4/7. 4 divided by 7. Whoa, 0.5714258714. Yikes. 1482. And then 5714. So do you think this part repeats again? Yeah, I think it actually does. So we can just write this as 0.571482 repeating. minus, and then 3/5 is 0.6. Okay. We've seen this before. So, before I let you try, I would say, where have we seen this before? And my question to you is, hey, instead of me doing this, because I know you've seen this before, why don't you answer the questions below? Okay? I won't give it to you here. You can figure it out, or look back at your previous notes, or watch the section 3.2 video.